Hi there, this is Math 8, Unit 2, Lesson 11, Writing Equations for Lines. Okay, so today's lesson gets a little bit more complicated, so hang in there with me. There's a few extra steps we're going to have to do as we go through this. So if you missed class today, you're probably going to watch this a little bit, and you might have some questions. Follow up with your teacher, and they're going to be able to help you out quite a bit, all right? So let's take a look at what we started with. We began first of all with some pictures looking like this, and it had coordinates for various points for this triangle, these shapes that were there. If you notice, it did not give us any coordinates for point E on this line. What we know by looking at the picture is we know that this line has a slope, doesn't it, right? And that slope value is going to be the same. It's a constant going all the way up there. And that slope allowed us last time to figure out how far up we go and how much to the right we go, to be able to say where the points are going to be. And so I could take a look and say, well, I could figure out this slope to see what's it going to be. The difference though is that if you notice, we're not starting at the origin, are we? We're starting right here. So when we take a look at this shape here, we notice that in the y value we're going from 2 to 7. So it's not starting from 0. I wouldn't just say 7 is my vertical. It's 7 minus 2 is my vertical movement up. And in terms of my movement to the right, I'm not just going over, well, in this case I'm starting at 0 here, I'm still going over 4. So it's 4 minus 0, or just 4. So my slope for my main line, we can see, is 5 over 4. Okay, just going to put that there for right now. That's just where my slope is at. That's what I know looking at the picture so far. It says to explain each, so find the following, explain your reasoning. We want to find the length of segment BE. So we want to find this length right here for how long that is going to be. So we're looking at this length right here for how long segment BE is going to be. That's question number 1. The length of that segment really is going to be what? It's going to be its y value, because that's going to be how tall that length is. We know where it's located, we just don't know how tall it is. So for example, as a coordinate, we know that it goes over, it starts at x equals 2, but we don't know the y value, do we? We don't know what that's going to be. It's some value that we're trying to figure out. That's going to be our length. Knowing what we know about other lines, we know there's going to be a relationship between the various lengths on the triangle. Okay? And so for example, my height here is, well, if I looked at my slope, my height of this one, this line right here, is equal to 5. Okay? So I know that that has a length of 5, and I know this has a length of 4. So my large triangle has a length of 5 and 4. Okay? Now because we're going this way there, that means that there's going to be, if you think about it, a scale factor that's going to make this drop down and become this length here. Now my length of the triangle is going to be 2 on the bottom, and I need to figure out what the height is going to be. So you want to ask yourself, how do you go from 4 to 2? That's going to be times a half, right? Times a half, because 4 times a half is 2. So what is half of 2? Half of 5. Half of 5 is 2.5. So my x value stays 2, which we knew, and my y value becomes 2.5. And we can place that in our space right here to say it's at 2.5, which answers this question here. What are the coordinates? 2 and 2.5. So there's a reduction there to figure out what that's going to be. Okay, we can do each one individually and say, well, the 4 times the scale factor gives me 2. My scale factor is going to be divide by 4, scale factor equals a half. And when we do that for 5, we end up with a 2.5 as well. Okay, so that's one way of looking at how that can be solved. Alright, so looking and comparing and using what we know to figure these things out. Let's look at the next side. On the next side, it says, what do we mean by an equation of a line? So we're going to start talking about equations today. An equation, which means it's going to have an equal sign. When we're talking about a line here, here we go. So first, what are the coordinates of B and D? Well, B is located at 4, 3. So B is at 4, 3, and D is located at 8, 8, 6. We're on the same line there, aren't we? Okay, so we have this nice line, and these are all on that line. Is point 20, 15 on the line, and explain how you know. Okay, well, if we took our 4, 3 to start with, all right, here's our first point, 4, 3, and we put that into the quotient, y divided by x. We have 3 over 4. If I looked at point D was 8, 6, and again, if I put that in the quotient form, I'd have 6 over 8, which reduces to 3 over 4, because 2 goes in there 3 times, 2 goes in there 8 times. So the question is, if I take 20 over 15, and I put that in quotient form, 15 over 20, do I still end up with 3 over 4? If I do, then that point is on that line because it shares the same slope. And as we find out, 5 goes in there 3 times and 5 goes in there 4 times. So we would say definitely, yes, it's going to work out. And the reason for that is we're starting at the origin once again. And because we start at the origin, it's going to be going along the same line and have the same slope there. It's going to work out okay. Okay, so look at number 3. Is that point on the line? So again, same idea, 75 over 100. Okay, well, how many quarters is that? Thinking about money, 25, 25, 50, and 75, 3 quarters there. How many quarters are in a dollar? 4. So we would say, yeah, it's the same slope. It continues there. If we look at this next one, number 4, is it on the same line? 68 out of 90. Well, 68 out of 90 reduces down to, I can do 34 out of 45, which is a crazy little number there that I don't really know anything that goes with it. And if I did 34 divided by 45, what I end up with is 7.755555, right? So it's going to be 0.755555 when I wanted just simply 0.75. That's 3/4. So what I know is that it's a little bit too large. It's close, but not the same. Close doesn't mean it's the same, okay? So it's not going to be on the line. It'll be near it, but it won't be on that line. So it says, suppose you know the x and y coordinates of a point. Write a rule that would allow you to test whether the point is on the line. Well, in our case here, we want to make sure that the y value divided by the x value is going to be equal to 3/4. That's what we're trying to say. Whatever we have has to be equal to 3/4. So if I was to write that another way, I could move the x value over to there, and I could say that y is equal to our slope times the x value. Okay, and that could become an equation there. It's the quotient of the y coordinate and the x coordinate, and it needs to be 0.75. So if I did it as a decimal, I could do 0.75x. You end up in the same spot there. All right, let's look at the third thing we looked at today, writing relationships from slope triangles here. And so here are 2 diagrams you had to look at. And we have our various points. They're on different spots along the line. We know that because they're right angles and they share this common line here, that they're going to be similar. So what can we tell about these lines? Well, it says first, complete each diagram so that all vertical and horizontal segments have expressions for their length. So we want to make sure we have a length there. Well, what is the length from here to here? It's kind of hard to say what that length is exactly. I'm not sure what that's going to be, but maybe we call it x. Okay, it has an x value, and we'll kind of call this one, we're going to call it x because it starts at 0. We're going to call this one y minus 1. We're going to call it y minus 1 because whatever the value of this is, it's starting 1 away from the origin there. That's our length right there. When I look at the other triangle in this picture, 2 triangles, sorry, mine's on paper, so I got to flip back and forth. Our x value in this case is starting a little different spot, isn't it? Here's where we're starting at. We're starting at 2 up here, and so we might say that's x minus 2 to begin with, and our y value is more like a y minus 4 because we're starting up here, not starting right at the where we want it to be. So this is x minus 2 and y minus 4. So when I take a look at this guy back over here, my original slope is 3, 4. And I can make that equal to y minus 1 over x. Okay? Or if I wrote it the other way around, which is probably a little better to look at, y minus 1 over x equals 3/4. Now when I move that x over there, we have y minus 1 equals 3/4 x. If I wanted to continue this, which we don't have to do today, I could add a 1 here, and y is going to equal 3/4 x plus 1. Don't have to go there quite yet, okay? You can stop right there if you chose to, and even this is pretty close for where we are right now. When we looked at the next one, because again it's a slope of 3/4, I have my 3/4 is where I'm at right there, and what we could say is that we take our y minus 4 over our x minus 2, and we set that equal to 3/4. Okay? And you can leave it right there like that. If you wanted to continue, you could say y minus 4 is equal to 3/4, and this would be times an x minus 2. And we'll get into that part a little bit later. Okay? So that could be another way of doing it, but really, all we're needed today is get that far. Okay, so find the area of the shaded region by summing the areas of the shaded triangles. Alright, got a lot of triangle stuff here. Let's see how this can work out. Alright, so this triangle here, this has a base of 12 actually. If that's 24, this is 12. We have 5 and 5. So these match and these match. So the area of this one, first of all, is going to be 1/2 of the base times the height. This one also would be 1/2 of the base times the height. Over here we have 1/2 of the base times the height. And over here we have 1/2 of the base times the height. So the value of that, when we sum that up, it's going to be 90. This one's going to be 90. This one will be 25. And this one will also be 25. Okay? So the combined area, 90, 90, 25, 25, ends up being 230 meters squared. Okay? Now for the next one, find the area of the shaded region by subtracting the whole thing, by subtracting the unshaded from that, which should work. What do you get? Well, this area here is 24 by 10, which is 240 meters squared for this space. The whole triangle has a height of, we'll do this, 1/2 of the base, which is 5 plus 24 plus 5. So our base is 34, 1/2 the base times the height. The height is 10 plus 24, sorry, 10 plus 15, which is 25. So the area of the triangle, the whole triangle, is going to be 425. Now if I do 425 and I take away the unshaded part, 240, we end up with 185. The problem we have here is that 185 meters squared doesn't match that one. They're different. So what's going on here? It tells us that this drawing, while it might be a nice drawing, isn't a realistic drawing. Something is not right. The numbers are off, is a nice way of saying it. Numbers are off. Okay, someone drew a picture and made up numbers, but in reality, that triangle, that shape, or those measurements simply cannot exist. Okay, so let's do a quick little summary of today's lesson. So you have points there, and today's summary is that the slope for a triangle is going to be found by looking at its vertical side, its horizontal side, and taking the quotient there once again. Okay, the two slopes, sorry, so you have two different ones here, two triangles. Two slopes must be equal since they form slope triangles with the same line. So you're going to have slopes that are going to be equal because they are part of that same line when you have two different triangles, the way this works out. As a result then, when you set this up, if we look at our slope in this case here, we know that this slope is y over x, right? You're going to have the y over x value for that one there. This slope is going to be up 2 over 1. So because we have a slope for a small one and a slope for the large one, we can do some cross products here and end up with 2x is being equal to y. Okay, So y equals 2x, which is right here. And then we can use that equation to prove that any point might be on the line. And we would plug that value in to show if that would be true. And that's where it's starting at the origin. If it's not starting at the origin, we might have to explain it a little bit differently here, okay? And that's because if you look here, our height in this case here is y minus 1, whatever that's going to be, because we're starting it at not at the origin. Our length is still x. So to solve for our slope here, you end up by saying that the vertical side has a length y minus 1 because the distance from y to the x-axis is y, but the vertical side of the triangle stops 1 unit short of the x-axis. So our slope is going to be written a little differently, right? It's y minus 1 equals x. So even though the slope still has a slope of 2 over 1, we set up as 2 over 1 equals y minus x, and that would mean that when we rewrite this, y minus 1 equals 2x, which is right there as well. And we could use that equation to solve for any point on the line as well. Okay? And that's how we get there. Again, eventually, this would become, by putting the 1 over there, y equals 2x plus 1, but that's for another day. You don't have to worry about that quite yet. So take a moment to do your homework and press pause, and then let's come back and take a look and see how you did. Okay. So here we go, homework for tonight. It says for each pair of points, find the slope of the line that passes through both points. If you get stuck, try plotting the points and see what you get. Okay, so slope of the line. To find the slope, we are going to do the y value minus the starting y value and the quotient of that and the x value. So we take, for example, 5 minus 1 over 7 minus 1. So in this case, 5 minus 1 is 4, and 7 minus 1 is 6, and that becomes 2/3. That's the slope for that one. For this one, we can do the y minus that y, and we do this x minus that x. We do our second one minus the first one each time, okay? And we have 6 over 4, which is 3 over 2. Here, we're going to do 2 minus 5 over negative 1 minus 2. Well, 2 minus 5 is negative 3, and negative 1 minus 2 is also negative 3. And negative 3 divided by negative 3 is a positive 1 for that slope. Here we have negative 4 minus 5 over negative 7 minus 2. This becomes minus 4 minus 5 is a minus 9. Minus 7 minus 2 is also a minus 9, which is going to equal a 1. Okay, so that becomes my slope that passes through, both lines pass through that point there. So again, if you were to plot this out, the idea is, let's look at the first one. If I had 0.11 right there, I have 0.75, so 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, and I plotted it there. What we're saying, since we're starting at the origin, is that this line here has a slope of 2/3. That's just that one there. They're all different. Okay? Let's look at number 2. Number 2, line L is shown in the coordinate plane right here. What are the coordinates of B and D? Okay, so B is located at 4, 0, 4, 0, and D is located at 8, 10. Okay. Is the point 16, 20 on the line? It might be, but if it is, then what I need to look at is, I can look at my 10 over 8 and reduce that down to 5 over 4. That's my slope, right? So if it's going to be on the line, it needs to have the same slope. 20 over 16 can be reduced. 5 goes in there, or sorry, 4 goes in there 5 times, and 4 goes in there 4 times. That's the same slope, so because it's the same slope, it would be on the line. For the next one, 24, the y value the quotient of the y and the x, 24 over 20. 4 goes in there 6 times, and 4 goes in there 5 times. 6/5 does not equal 5/4, so we would say no for that one. That point would not be on the line. Keep going with the same question, still using 5/4 as my slope. We want to see if this is on the line. Again, our goal is we're talking about 5/4, so is 100 over 80 on the line? Again, I can reduce, I can take off the zeros, and 2 goes in there 5 times, and 2 goes in there 4 times. So because that's equal, it would be on the line there. So what rule would allow us to test whether it's on the line or not? Well, the idea is we're saying that y over x equals 5 over 4, or written another way, we would say that y equals 5/4 x. Okay? Either one of those is going to work for a rule that will allow us to put any point in to see if it's going to work or not. This is what we did the first time, and that becomes an equation that you might set up to solve for that as well. Number 3, consider the graph line. Maya uses triangle A and says the slope is 6 over 4. Elena uses B and says no, the slope is 1.5. Do you agree with either of them? Well, let's take a look. For the first one, triangle A, we're going up 1, 2, 3, 4, 5, 6. Okay? So for triangle A, we're going up 6 and we're going over 1, 2, 3, 4. 6, 4. That can be reduced to 3 over 2. 3 over 2. Now 3 divided by 2 written as a decimal is 1.5. What's happening with letter B? With letter B, I notice that I'm going up 1.5 and over 1, which is still the same as 1.5. Do the slopes match? The slopes do match. And because the slopes match, we would say they're both right. They just have a different way of using it. One person is using a fraction and the other is using a decimal. So, important to take a look at that, make sure you know how that works out there. Number 4, our last one today. You have a rectangle with length 6, so there it is 6, and a height of 4, and a height of 4. There it is. Which of these tell you that it's not similar? Well, let's just make it up here. We're going to call this A, B, C, D to help you kind of visually see what's going on. Okay? So which of these would tell you that quadrilateral ABCD is definitely not similar to this rectangle? So we want to show that it's not similar. AB equals BC. Okay? Does that prove that they're not similar? Yep. So we'd say, yep, that proves it's not similar. If AB equals BC, then we have a problem, and that's not going to work. Not similar. And measurement angle ABC equals 105. If you had ABC equal to 105, then that would not match our thing, and so we would say not similar because ours are all going to be 90 degrees. If AB equaled 8, hard to say. It could be true. That could be a scale factor times 2, scale factor of 2, and so it might work. So I can't prove that it's not the same. Same for BC. There might be a scale factor there that makes that work, so we're going to say no. BC equals 2 times AB. So this length equals twice this length there. Okay. Does that prove that it's going to be similar or not similar? Nope, not going to help me prove that there because that actually could work out, so not going to work out very well. And F, same idea. We have 2 and then we have 3. That's just not going to work, so we'd say no. So we're going to go A and B and E, just kind of fun to think about, and I didn't do a great job explaining that as I realize it, but you'll be all right. Sorry about that, and we'll see you next time.